Bootstrap Unit 8 starts with this little question and consideration about what distance means and what it means for edges of items to overlap. Is that, um, so you're looking for the distances between these edges. At least that's what they want you to consider right now. The next slide has this image. Before you actually read through what they're talking about here, I do want to quickly note that the centers of these circles should theoretically lie at the distance or unit 1 and unit 4. Next thing you need to note is that the radius of the smaller red circle is 1 and the radius of the larger circle is 1.5. This is all example, but it's to help you understand this main sentence in here that is quite difficult to conceptualize just, well, at least for me because I'm a visual person, it's difficult to conceptualize because it's just a bunch of words, honestly. To break down this sentence, I actually have a little visual of the actual distance between the centers, and then I had a little drawing to try and illustrate this idea. The distance between the centers is less than the sum of the radii. Right here, looking like this, but it doesn't really show anything. It just identifies those two distances. So I thought it actually might be a little bit better for you guys if I have a clearer visual. Let's see this. I don't know how that distance changed. I programmed it so that this distance would be 1.5. It's fine. You guys get the idea. Don't know what's happening here. Oh, that's why. So this shouldn't be 1.7. This should be 1.5. Okay. Now, these two shaded distances between this vertical C and D, that's just to indicate the distance that is the radius for each circle, or the radii of both circles. And so these two distances, the sum of the radii, if I put those two together, so 1 plus 1.5, that should be less than the distance between the centers of the circle. Because if not, they overlap. So it's hard to understand. There's just a lot of terminology. So the two distances, okay, that's what these are. If, ignore the shading changing like that. That's not what I want. I don't know why it's showing them as this weird slanted figure here. Well, I'm having trouble now. Give me just a second. Alright, I'm retrying this again because I had too much trouble with the GeoGebra tool. I just don't understand it well enough to be able to use that. Whereas Desmos, I understand pretty well because it's all algebraic. So anyway, you have the two circles. I redid it. And I have the two areas, or the two distances highlighted based on these gigantic vertical shadings. So those indicate the distance of this radius and the distance of this radius. And then I have this shading. This is the distance between the centers. So this is the distance between the centers. And this needs to be, if I want my circles to overlap, this distance here needs to be less than, so what they're saying is less than the sum of the radii. So less than those two put together. So if I increase, let's see, I don't know what that slider is. Oh, I see. So if I increase the radius distance, which I don't want you to worry too much about what you're seeing here, but let's say my radius for the first circle is increased by 2. So it's now 2 there. So those two, it looks kind of funny because there's an overlap, but basically the darker shading is my first radius and the lighter shading is my second radius. Okay, now if I do this, then the distance between the two circles is less, because if you'll notice, this is just one straight distance, but these two, it's the straight distance plus that overlap. Okay, so as we go through the lesson, hopefully that will become clearer. It's kind of a strange idea to work through, but it is something that you guys need to explore, and they have the math here for you as well. If I open up the blank game file, I see, and scroll down, so I know your game file should not be blank anymore. You should of course have been saving, and you should have, let's see, your graphics filled in, your update danger and update target filled in, your safe left, safe right, and on screen. And then your update player is what we just did in Unit 7. And now we're on to Unit 8, which is this function with line length, distance, and collide. Now, line length, they tell you compute the difference between 2 points on a number line. And if I look, the distance between 2 points on a number line. Okay, they have some examples from it for us here. And notice that line length of 2010 takes the two numbers and it's going to give me a new number by performing the operation. I'm going to subtract 10 from 20. So they will want you, what would you expect from each of the following two uses? So line length 2, 5, or 2 space 5. Oh, I hadn't clicked run. Sorry. Yeah, I should have done that. Because if I don't, then there's no function line length typed into the program. 2, 5. So it gives me 3. Does, wait, 20, 10. 20 should be the first number. So it should do 20 minus 10. So shouldn't this do 2 minus 5? It should look like this. Negative 2, or minus 2, 5. That gives me negative 3. So why are the numbers coming out differently? Oh, I see. I see. That's going to show up later. And then it says line length 5, 2. Okay, then I have 3. Again, so 2, 5, 5, 2 gives me 3 for both. That doesn't exactly match what I'm seeing with these two examples. So we need to look at this a little bit deeper. That deeper consideration comes when you read through what the next slide tells you, and then it says, and what you're seeing here. They gave you 2010, 10, 20. Define, so this is your function name, variable, variable, conditional, meaning we have two possibilities because I'm seeing two clauses. Either, so basically if A is greater than B, then it will do A minus B. Or else, they will do B minus A. So let's consider that. Let's consider that the example of 2 and 5 that we just used. Where's my, whoops. So if, so we have A equals 2, B equals 5. So if A is greater than B, then they will do minus A, B, meaning 2 minus 5. But is that true? Is 2 greater than 5? No. So then they'll say instead we're going to do, so instead we're going to do minus 5, 2, because they switched it right here. So you had to consider, why would it do that? Why does line length need to have this conditional setup? This, if this is true, then we do it. Instead, if not, then we do this. Why is that happening? That's something I want you guys to be able to answer on your own. I have really held your hand through this process, and I regret it. I'm very sorry for that. Read through this next slide. This next slide gives you a little bit of information about how you're going to start calculating that distance between those two centers. and it references what we've already been talking about, this function line length. It's very crucial. You can use line length to find A, you can use line length to find B, and so how can we use those two things to find C? 2 seconds to process that. If you consider the structure of the figure that we're looking at here, it actually refers back to something that you should have heard of from geometry and from trig and so on and so forth, and that is that we have a hypotenuse. I still have my students in trig, when they draw a triangle, to identify the hypotenuse, I tell them, if you're confused, draw an arrow straight from the right angle, and there's no way it'll go anywhere but the hypotenuse. Now, if you're looking at with respect to those two circles, your hypotenuse is that distance between the centers. But gotta pause for a second so I can do a new drawing. What I was trying to say is you have your hypotenuse, which is the distance between the centers. If your hypotenuse is less than these two radii put together, if there's some sort of overlap in the radii here, then that means that you have a collision. Your next slide has some information about 2D distance. Then it has a link to a video. I highly recommend that you watch it. It's possibly one of the best visual representations of the Pythagorean theorem that I have ever seen. It's just clear, straightforward. There's nothing that I think could be confusing about the way that it's worked out. Give it a try, and hopefully then you should be clear with the Pythagorean theorem. If you don't have time to watch the video, the next slide opens up in the same way. Give you a second to look through that. I'm going to switch slides now. And then the next slide has a visual for you as well. This is all still summarizing what's in the video. All right. Same thing here. All right, now this is actually something important that a lot of people forget about the Pythagorean theorem. If you're trying to find the length C, that hypotenuse or the distance between the centers of the circle, then you need to take the square root first. And that's actually going to factor into the way that we calculate our work here. So it says to turn to page 29 in your workbook, which is not the word problem for line length, which I don't remember the workbook mentioning this. Ooh, did I skip something, guys? Give me just a second. Let me pause it. Yeah, it looks like for some reason they didn't have us in the slides go over the word problem line length. Not exactly sure why. If you had any trouble with what was going on with that, you do have this that can help you figure out where the coding comes from. Anyway, so page 29, you've got a distance formula here, which is the formula that you just used to calculate the hypotenuse. But A and B, those are the line lengths that we can use. And so to find the distance between these very two specific points, 0, 0, and 4, 3, they actually have, instead of just doing 4 minus 0 and 3 minus 0, they use line length 4, 0 and line length 3, 0. Just like before in past videos when they ask you, do you want to use a simple function that references other simple functions, or do you want one big giant complicated one? That's what they're doing here. They have a simple function to make this pretty intense calculation a little bit easier. And then they have this circle of evaluation that you will convert into racket code. I want you guys to pause the video and try filling in the circle. I will unfreeze the video or unpause in just a second and show you my circle of evaluation, and then again you'll pause, turn it into racket code, and then I will show you my racket code for it. I'm going to give you a few more seconds. All right, I'm going to show you my circle of evaluation. Now I want you to pause the video and make your bracket code. And I'm going to show you my answers now. Should follow the general structure of what you expect for something like this. You're going to take the square root of the sum of these two squares, which come from doing that line length function. The next slide wants you to consider what it would be to make a function that doesn't just take the points 0, 0, and 4, 3. And when I talked about this formula here, I called it the distance formula, but it's not actually. This is just an example, or this is just one calculation. A formula is taking in a set of different variables. And if any of you have any experience with the distance formula, you'll remember that there are 4 different variables. In this case, the 4 variables that they're taking are, I'm sorry, I blanked for a second. The 4 variables they're taking in are the coordinate, the x and y coordinate of the player, and the x and y coordinate is of another game character, which we'll talk about in a little bit. And so it says it wants you to return the distance between the two using the distance formula. I rewrote the distance formula that we had last time, although I do think, what I had last time was, sorry, my pen is turned off, was all in one line. I think it's better written when you do it in this staggered format, and they actually try and do that a little bit in the examples here for you, although that's partly because it just doesn't fit on the same page, same line. But you say you're opening up the function square root, and then you're going to take the sum, and the square root is it's of the sum of these two squares that are the line length function. And that's basically exactly what I said when we were looking at the circle of evaluation racket code. But you have this visual structure to show you that the square root is of the sum of these two squares. I mean, it shows you that this is a subsection of this, which is a subsection of this. All of this is just blending together to look like one line. It's a little bit not as efficient. So I want you to take a minute and try and write this formula. I'm going to pause it and I'll write mine in and I'll let you know when I'm going to unfreeze it. I'd like to show you my answers now. Wait, maybe I didn't give you enough time. Okay, now I'll show you my answers. Well, sort of. So far, I put in my contract, my purpose statement, and I did my examples, but I haven't actually identified what changes to give my variables or to know where my variables actually go. So I'm going to do something a little different this time rather than just doing a bunch of circles because it's going to be really hard to show here. I see the square root change, distance stays the same. And then I got these 4 numbers. I know those are going to change. And see, this is px, this is py, and I noted my 2 points that I was using. This is cx and cy. Px, py, cx, cy. I note that the square root plus stays the same, square root line length stays the same, so then it's just the numbers that are changing in each case. This here, this first number is cx. This second number, or this number, the first number in my second example, that is also cx. So that tells me, well, I already said that the square root, the plus, the square, line length stays the same. But then the next thing that shows up is that changing cx. So cx is next. And then that 1, that's px. Let's see. That 10, that is px. So then my next value is px. Let's see. Then after both of those is, well, that's messy, but it's parentheses to close off line length, parentheses to close off square. Then square opens up again in both. Parentheses line length. I'm out of space, so ignore that parentheses. Then the next thing is something that changes. So let's see, 5 is cy, 1 is cy, Whoops, that's an ugly y. But cy is what comes up next. Then 2 is py. 2 here, well that just happened to be the case for both, is py. So then closing up line length, closing up this square, then I have to close up that plus sign, then I have to close up the square root at the front. And so this function here follows the structure of the distance formula that I have, but instead of saying specific numbers, it's saying that we're going to subtract the x's and we're going to subtract the y's. Now, I'm going to make a quick note. Some people might still want to try and do something like minus cx px. But the problem with that is, in this case here, cx and px, if you'll notice that's 7 and 10. 7 minus 10 would have gotten you a -3. That is not a valid distance, and that would cause your program to crash because it's saying that you're getting a negative distance. But line length, so if you'll remember what we did, said, well, if cx is bigger, I'm going to do that subtraction. But if px is bigger, I'm going to do this subtraction. So that's another reason why we want to include line length in this formula, in this definition. Read through this next slide. Read through this next slide again. This one has some work that I want you to try and do on your own. Change slides now. Whoop. Please read through this slide. I'm going to change it. Please read through this next slide. Your next slide asks you to look at page 31 and look at this design or write the design recipe for a function called collide question mark or collide and determine. So it gives you some information here that your workbook does not. It says write a function that produces true if the distance between the coordinates is less than 50. So the design recipe, I've already started mine. I did my function name and my domain, and I know my domain comes from taking in 4 inputs. And so it says it takes in the coordinates to determine if the distance is less than 50 pixels. And this less than should be a big indicator about what type of result you'll have in case you didn't look at the slideshow before. But it says it returns true. The only function the only type of function or data type that I have that can return a true is a Boolean. So that's my range. That's what I will be returning. Now, it wants me to write some examples. I'm actually, rather than pausing this video, I'm going to do this one with you guys because it's a little bit harder to do with, not harder, but for me it's a little harder to conceptualize what's happening. I know my function name is collide, every time. Now my input, I'm going to take in the coordinates. I'm just going to use, I don't know, just a couple of random points, 1, 2, 3, and 4. 0.12 and 0.34. Let's go with 4, 3, 2, 1. I don't care. They're just random numbers. That's what an example is anyway. And let's see, so I want it to determine if the distance is less than. So that means I'm going to be using the less than function. And I'm comparing the distance, which I defined to be distance last time. So I'm using the function from the last bit of work, kind of like we did from lesson 7 to 8 with, no, kind of like we did with line length to distance. Anyway, so I need my distance, which, if we'll remember, distance took in 4 numbers as well. It took in the coordinates, 1, 2, 3, 4, and 4, 3, 2, 1. And I need that distance to be less than 50. See, so that's closing up the less than, and that's closing up the example. See, so I again need it to be less than 50. Close up that less than and close up the example. Yeah, so what this should tell the computer is, I've got two coordinates. Do they collide? And the computer will say, well, the distance between those coordinates is whatever. And is that less than 50? Because if that distance between the 2 points is less than 50, then that means that they are essentially too close and they are colliding. And it does that for both of them. So this looks like this should work. Before I start circling my variables, what I actually like to do whenever I'm not doing it with you guys, I just go into my code and I write down everything that does not change. I may have said that to you guys before. I've probably repeated myself like crazy at this point. You guys are ready for this to all be done. Let's see. So I need a parentheses to close the less than, and this parentheses will close up the define, and that's right there. Alright, and now I go through and circle what has changed. 1, 2, 3, 4. 1, 2, 3, 4. Let's see, and the 1 and 4, that is px. That's the x part of my coordinate. 2 and 3, that is py. 3 and 2, I circled really badly there, cx. And then 4, 2, I'm sorry, 4 and 1, again, circled really badly. That is cy and cy. So px, py, cx, cy. And in this distance function, when I replace those, it's going to be in the same order. Because the distance function is where the order is off, which we just saw. So I'll give you guys a second to take that in. And I'm going to go to the next slide. The next slide is actually the closing to the game. So there's a ton of stuff that you guys have gone over. My students in class have been telling me how frustrated they've been just because, you know, little things will slow them down quite a bit, and you're probably experiencing something like that as well. But I just wanted to show you guys my coding because it should look very similar to yours at this point. You should have had some code that was pretty intense as well. You got your game title and your graphics. You have making your update danger and update target where they actually move on a regular basis. Your safe left, safe right, and on screen. I said saved to make sure that all of your stuff comes back to the screen. You have and then you have your update player, which we'll look at in just a second. You have collisions, which is what we just talked about, where first you have to define the line length, and you use that to define the distance, and then you use that to define the collision. They have this function that's in here, a final secret, where you can use a mystery function. I don't think that I ever did anything with that. Yeah, I didn't do anything with it. I don't know what that is. Oh, you know, I do know what it is, but if you want to look into it, you can look into it a little bit more. I'm not something I'm going to do. And then you have your code down at the end, which we'll talk about in a minute. So before I go further, I mentioned this with the Unit 7 video when you were talking about warping. So I have warp to top, warp to bottom, warp to left, warp to right, hide code. Then I have a speed code where the students or the player can actually go faster than just the regular up, down, left, right. So my update player may look a little bit different than yours, but everything else should be basically the same. Okay, this is a lot of coding to have written. You should be incredibly proud of yourselves for getting this far. I will say I did try doing some fun stuff with my, let's see, so I don't think you guys have, I don't know if y'all seen my game actually. So this is my game. This is my shark. and he is chasing the scuba diver and trying to avoid the submarine. Notice that my shark can actually move left and right as well. That is something that you would have to practice on your own. That can get you some bonus points with your Bootstrap game if you'd like. Um, ooh, I got hit. And my shark can, as I mentioned with those codes, hide. Can, let's see, where's my, I don't know the key pushes for my shark to move faster. There's the warp to right, warp to top, I don't know. Well, either way, so my shark moves a little bit differently than y'all's, but if you wanted your shark to move like that, you could. And I spent some time doing a fun submarine movement, which used a sign function. I don't know why I have this thing that says need to edit. I took it out. I don't remember why, but I used a sign function for my submarine to move, so that way he could actually move up and down on the screen in a wave pattern, and my shark had to move a little differently to adjust. But I took it out, I think because it was changing when I had my left and right coding. Don't cheat and use my coding to try and figure out left and right. Actually work through it. And we'll see if there's anything else I need to mention real quick. There is definitely something else you need to see. They've got some questions for you to make sure that your code looks good, to kind of check through everything. Do you have a function contract for every function? Does every function have a purpose statement? Does every function have at least 2 examples? And when you click run, do all of your examples pass? And you guys have seen many of my examples, not many, but you've seen a few of my examples actually give me an error message, and that needs to be something that does not happen when you work through it. Okay, so this is something that you should do to check through your game, and that is something that I will definitely be looking for whenever I grade it. Now, after looking through everything, it looks like you guys have done everything that that you would need. Now, I would recommend that you take a look at the supplemental lessons and see if there's anything else that you can do to kind of go further in your game or go further in your programming. Again, be proud. You've done some great work.